All right, hello my friends. Got some more problems. So for this one, we are going to be taking some derivatives of some crazy functions. These functions were made to be kind of deliberately complicated so you can try out some tricky derivations. So remember, a derivative, when we take a derivative, all we're doing is we're finding a function that gives me a slope uh, as a function of the independent variable. So for example, if I have the position x of t as a function of time, and I take the derivative, then the derivative will be the slope of x as a function of time. And the slope of the position is the speed, or the velocity. So the velocity as a function of time is the derivative of the position. So with these crazy problems, we're just coming up with a function that is the slope of those functions. Okay, so for a, we have f of x equals cosine of x times x. Okay. So this is going to be a product rule. So the product rule says that if you want to take a derivative of two functions that are multiplied together, or three for that matter, then the derivative is, so we're taking the derivative of this product. So df by dx, we take the derivative of the first one, leave the second one alone. Leave the first one alone, take the derivative of the second one. So for this one, when I do d by dx of cosine of x times x, derivative of cosine of x is negative sine of x. Leave the other one alone. Derivative of x is 1. So then I have plus cosine of x. And that'll be your derivative for that one. Okay, part B says 1 over the cosine of, it's 1 over the same function. So now we have f of x equals 1 over cosine of x times x. Okay. So what does this look like? Well, I can rewrite this like this. Cosine of x times x, whole thing to the negative 1. So this is going to be a chain rule differentiation. So the chain rule says that if you want to take the derivative of a function, but the function you're taking is a function of another function. So like we have f of g of x. Then what we do is we take the derivative of the outside and leave the inside alone. And then we multiply this by the derivative of the inside. Okay, so let's see how that works for this one. So for this outside that we're dealing with, this problem is this negative 1 exponent. So if I want to take the derivative of this thing, f of x, where f of x is this f of x, then I will get the derivative of the outside, which is negative 1, while leaving the inside alone, cosine of x times x, and then this gets knocked down, so this goes to minus 2. And then now I multiply the derivative of the inside. Derivative of the inside I know is right here. So this is cosine of x minus x sine of x. Okay. So then we have negative 1 divided by the cosine of x times x squared, and then multiplied by the derivative of my inside. Okay, part C. So this one we have two functions, f of x comma y equals x squared plus x times y plus e to the y. So this one I'm trying to get you to recognize that Y is an additional independent variable. So when I take the derivative with respect to x, then for this, in terms of this derivative, y is basically a constant, right? So I will get 2x plus, and then for this one, y is a constant. It's a number. I don't have to take the derivative. So I just have to take the derivative of this. So then this will be plus y. And then my last term is only a function of y. There's no x's in there. And the derivative of a constant is 0. So you get 2x plus y. Then for part D, we're doing 1 plus the sine of x squared plus the cosine of x. You can see I was getting a little creative. So then df by dx. Your 1 is just going to give you a 0 term. Don't care about that. So this is a chain rule. I'm going to take the derivative of the outside. So that's cosine, derivative of sine. And I have x squared plus cosine of x. Now I multiply it by the derivative of the inside, which is 2x minus the sine of x. Okay, I'm just taking, so I took the derivative of the outside, cosine, left the inside alone, and then multiplied by the derivative of the inside, which is 2x minus sine of x, because the derivative of cosine of x is minus sine of x. And then part E, oh, we got a crazy one. So we have e to the sine of 4x times the natural log of x plus x squared. Okay, so it's a product rule and a chain rule. So here, let me move my picture. Hopefully that moves for you. So these derivatives of these exponentials. So I'm going to take the derivative of this term, leave this one alone, and then vice versa. So these derivatives of these exponentials, you're always going to get a term like this. The special thing with the exponential. And then now I have to multiply by the derivative of the inside. Derivative of the inside is cosine of 4x. Now I have to multiply by the derivative of this inside, which is 4. And then I still have natural log of x plus x squared. And then this gets added to, leave the first term alone, plus, or not plus, multiplied by the derivative of the second term. Derivative of the second term, well, derivative of a natural log is 1 over the inside. So we have 1 over 1 plus 2x. Oh, no, sorry, that's right. So leave the inside alone. So that's x plus x squared. You can see I was kind of jumping a step. So we have 1 over x plus x squared, and then multiplied by the derivative of the inside, which is 1 plus 2x. So this crazy term is df by dx. So really the only rules you need to know are the product rule, which is right here, and the chain rule. Sometimes people call the product rule integration or by parts instead of the product rule, but same thing. Also, sometimes people talk about a quotient rule as well, but you see that the quotient rule is just the same thing as a chain rule. It's nothing. I guess my mic died there. I hope you can still hear me. That is going to wrap up our problem. I'm going to put my face right here so you can pause it and check your answers.